I've had several questions about number 9 and the homework for chapter 25. So I thought I'd talk through the example a little bit, or talk through the problem a little bit in the context of the example. All right, so here we go. We have our equation up here for the distance to the image, right? And we have down here the focal length, and we have the distance to the object. Now, things to note, right? Things to note. The focal length is in millimeters, and the distance to the object is in meters. So one of the things you have to do is convert everything over to meters would probably be one way to do it. Or you can convert everything to millimeters. It doesn't matter which, as long as you know what you're doing, right? And millimeters in this instance might not be a bad unit to convert to, because we're also talking about film, which is only 36 millimeters high, a standard 36 millimeter film. Okay, so you've got the focal length in millimeters, you've got the distance to the object. We're going to convert that over to millimeters, so it's 2,220 millimeters away. That's going to give us, when we use this, that's going to give us the distance to the image in millimeters, right? Well, once we have the distance to the image, we can look here to this equation, right? We can look here to this equation. We've got the distance to the image, we've got the distance to the object, so we know the magnification, right? Once we know the magnification, we take the next step. We've got down here, right? And we've got down here the height of the object. We've got from the magnification and the height of the object, we can figure out the height of the image, right? The height of the image has nothing to do with the fact that the film is 36 millimeters high, okay? That's just a fact. The film is 36 millimeters high, but we take the magnification, we take the height of the object. Again, we've got the height of the image in millimeters when we come out of this first equation. I mean, we got the height of the pardon me, when we come out, we got the magnification. This is in meters, right? You might want to convert that to millimeters to get the height of the image in millimeters. All right, why millimeters? Again, at the very end, we're asking what percentage of the image fits on the 36 millimeter film. All right, so you've got a lens. You have some guy standing over here, right? This lens makes an image. Over here, and the film is only yay big, right? So what fraction of the image fits on the film? Well, you take the film height, right? Height of the film. I can't really write like this, but we'll try it anyway. Height of the film, and divide it by the height of the image. And that's going to tell you what fraction of the image fits on the film. Now, you're going to get a negative sign for the height of the image if you carry your signs through all correctly. That's fine. We're going to ignore that. We're just going to treat it all as positive at the very end here to get the fraction. And this, of course, have to multiply by 100%, right? To get the percent. Okay, so to review, convert everything to millimeters, right? That's probably a point where a number of you are missing what's going on. Convert everything to millimeters. Find the distance to the image. Use the distance of the image and the distance of the object to find the magnification. Use the magnification and the height of the object to find the height of the image. Use the height of the height of the film divided by the height of the image to determine what fraction of the image will fit on the film, and then multiply by 100% to convert to a percentage. And that's it for problem 9 on chapter 25.